So hello everyone and I welcome back to the phenomenal session which is none other than electromagnetism. If you are getting stuck in case of electromagnetism, I promise my dear most children, after an hour or 50 minutes, the electromagnetism will become your best friend. I repeat my dear most children, the electromagnetism will become your best friend. And not only that, but also my dear most children, if you get stuck in case of numericals, in case of electricity, अगर तुम्हें लगता है इलेक्ट्रिसिटी हमसे नहीं बनता, it is very difficult for us, you have to make your weapon strong in case of electromagnetism. Why, my dear most children? Because in a unit of ICSE class 10 semester 2, एक यूनिट में तुम्हारा 3 चैप्टर बनता है बेटा. पहला क्या होता है? दैट इज इलेक्ट्रिसिटी, आफ्टर दैट हाउस होल्ड सर्किट, आफ्टर दैट इलेक्ट्रोमैग्नेटिज्म. हाउस होल्ड सर्किट तो बन जाएगा तुमसे बिकॉज देयर इज हैविंग लिटिल बिट थ्योरेटिकल पार्ट. बट कमिंग टू द इलेक्ट्रिसिटी, कमिंग टू द मैग्नेटिक इलेक्ट्रोमैग्नेटिज्म, इलेक्ट्रिसिटी समथिंग वेरी न्यूमेरिकल्स एंड मैक्सिमम स्टूडेंट्स दे डजंट लाइक एनी काइंड ऑफ न्यूमेरिकल्स. सिमिलरली इन केस ऑफ इलेक्ट्रोमैग्नेटिज्म, बात तो बहुत कुछ समझने का है, बच्चों बहुत कुछ समझे नहीं है इलेक्ट्रोमैग्नेटिज्म में. एंड माय डियर मोस्ट चिल्ड्रन, वेट फॉर 50 minutes to an hour. मुझे अच्छे से सुन लो, उसके बाद इलेक्ट्रोमैग्नेटिज्म विल बिकम योर बेस्ट फ्रेंड एंड वेदर इट विल इज बिकमिंग और नॉट, यू हैव टू कमेंट राइट देयर. यस माय डियर मोस्ट चिल्ड्रन, यू हैव टू कमेंट राइट देयर. सो विदाउट मेकिंग एनी डिले, लेट अस स्टार्ट वन ऑफ द phenomenal chapter, one of the scoring chapter, electromagnetism. Yes, I will be even discussing all kind of important questions, all kind of favorite questions of the ICSE board members. The question which generally repeat in every year, the question generally comes in the board examination, the question which will be coming. I am having lots of confidence on myself. जो मैं बोलूंगा वो क्वेश्चन आएगा ही आएगा. Those question also I will be letting you do, and also I will be letting you know how you people can write those question, how you people can write 3 मार्क का क्वेश्चन. हम तुम्हें लिखना कैसे है? पढ़ तो सब लेते हैं, everyone they read, everyone they memorize, everyone they practice, but they don't know how to write. Whether you are a topper or whether you are a below average student or an average student, you don't know yet how to write a 3-marker question in physics or 2-marker question in physics. I will be letting you know each and everything in the particular video. Without making any delay, let me. Many students they used to ask me, sir, please give a brief introduction about yourself, as you don't give any kind of brief introduction in any kind of video. So let me give a basic as well as short introduction about myself. That I am your SRM sir. Recently I have joined Unacademy, the India's largest online platform, as you can see the logo in my t-shirt even though. And I am the youngest educator in Odisha to join Unacademy, and I have mentored more than a lakhs of students in on and off the field, and having 8+ years of experience, and I have started my teaching career in the age of 15, I can say that. So this is all about. So without making any delay, let us start electromagnetism. And yes, after this video, electromagnetism will become your best friend. Please, my dear most children, hold the pen in your hand, hold the notebook, and start electromagnetism. Electromagnetism, in the other word also you can say MEEC, magnetic effect of electric current. Electromagnetism को भी हम बोल सकते हैं magnetic effect of electric current, as well as electromagnetism is derived into 2 types: magnetic effect of electric current as well as EMI, electromagnetic induction. My dear most children, please note it down as much as possible, as soon as possible. That is magnetic effect of electric current. EMI stands for electromagnetic induction. Magnetic effect of electric current has been propounded, has been discovered by the famous scientist, which is none other than Hans Christian Ørsted. Hans Christian Ørsted. Hans Christian Ørsted in the year of 1820. उसका मतलब ये होता है magnetic effect of electric current generally propounded, generally discovered by the famous scientist, which is none other than Hans Christian Ørsted in the 1820. बात खत्म. Even he stated that wherever the current flows, there the magnetism is present. That means here he's given a statement that current जहां रहता है वहीं पर magnetism रहता है. करंट चलाओ मैग्नेटिज्म प्रोड्यूस होगा, करंट ना चलाओ मैग्नेटिज्म प्रोड्यूस नहीं होगा. हु इज सेइंग दैट? हैंस क्रिस्टियन ओर्स्टेड. लेट मी गिव एन एक्सपेरिमेंट एंड द फर्स्ट क्वेश्चन इन द बोर्ड एग्जामिनेशन दैट इज डिस्कस द एक्सपेरिमेंट डन बाय हैंस क्रिस्टियन ओर्स्टेड. व्हाट इज द एक्सपेरिमेंट? डिस्क्राइब द एक्सपेरिमेंट डिस्कस्ड बाय हैंस क्रिस्टियन ओर्स्टेड. 3 मार्क का क्वेश्चन. कैसे लिखना है उसको? इट इज बीन प्रोपाउंडेड बाय हैंस क्रिस्टियन ओर्स्टेड इन द ईयर ऑफ 1820. उसके बाद कैसे उसको देखो. लेट अस डू एन बैटरी. इन अ बैटरी a conductor is, you know very well, these are the positive conductor, current is going on and here it will reflect. स्विच लगा देते कुछ इस प्रकार का. देखो here हैंस क्रिस्टियन ओर्स्टेड is saying that करंट, जहां करंट चलेगा वहीं पर मैग्नेटिज्म चलेगा, जहां करंट नहीं होगा मैग्नेटिज्म नहीं होगा. दैट मीन्स हियर द करंट इज फ्लोइंग एंड नॉट ओनली दैट देयर इज हैविंग अ मैग्नेटिज्म. व्हाट हैपेंड नाउ? हैंस क्रिस्टियन ओर्स्टेड ही डन एन एक्सपेरिमेंट दैट आफ्टर बैटरी, आफ्टर स्विचिंग ऑन द बैटरी, जब करंट चला, हियर ही हैज केप्ट अ मैग्नेटिक निडल, मैग्नेटिक कंपास. क्या ना वो मैग्नेटिक कंपास, ही केप्ट मैग्नेटिक कंपास. जब करंट पास हुआ तो मैग्नेटिक कंपास स्टार्टेड डिफ्लेक्टिंग. वो वर्ड को याद रखो, डिफ्लेक्टिंग. व्हाट हैपेंड इन केस ऑफ हैंस क्रिस्टियन ओर्स्टेड एक्सपेरिमेंट में ये हुआ दैट व्हेनेवर द करंट फ्लोस the magnetism produced. How magnetism produced पता चला कैसे ना? he kept a magnetic compass beside of the conductor, beside of the wire, pass में nearby the wire, and when the current flows magnetic field started deflect. मतलब कुछ इस प्रकार का है, उसका कुछ इस प्रकार का है. सपोज ये बंद है, when it is closed, when there is having not a single flow of current, when there is having not a single flow of current, जब करंट फ्लो हुआ तो कुछ इस प्रकार का लेकर कुछ इस प्रकार हो गया, डिफ्लेक्ट हुआ. जब करंट फ्लो नहीं कर रहा तो कुछ इस प्रकार का होगा, इस प्रकार हुआ, डिफ्लेक्ट, स्टार्टेड डिफ्लेक्टिंग. क्लियर बात? सो व्हाट हैपेंड? द फर्स्ट क्वेश्चन इन द बोर्ड एग्जामिनेशन दैट डिस्कस द एक्सपेरिमेंट डन बाय हैंस क्रिस्टियन ओर्स्टेड. हियर द एक्सपेरिमेंट डन बाय हैंस क्रिस्टियन ओर्स्टेड, दैट फिगर बनाना. देन आफ्टर यू कैन से दैट the magnetism can be produced if there is having a flow of current. The magnetism is not produced when there is having not a single flow of current. बात खत्म. These are the experiment he done by Hans Christian Ørsted in the year of 1820. Not only that, but also करंट तो आया, मैग्नेटिज्म प्रोड्यूस हुआ, डायरेक्शन बताना है. एंड व्हाट हैपेंड? What is the direction of magnetic field? What is the direction of magnet? Direction, जैसे यहाँ पर डिफ्लेक्ट हुआ, very interesting. जैसे यहाँ पर डिफ्लेक्ट हुआ, here it started deflecting. Where it got started deflecting? To the north pole, to the south, or south to the north, east to the west, west to the east. East west तो होता नहीं है generally, but I am saying an example where what is the direction of the current over here? What is the direction of the magnet? Sorry, what is the direction of the magnetic field over here? उसी को नाम रखने के लिए और एक साइंटिस्ट आया बाबू, उसका नाम है मैक्सवेल राइट हैंड थंब रूल. दैट मींस मैक्सवेल को हटाओ, अभी मैक्सवेल का बात थोड़ा बाद में करेंगे. दैट इज राइट हैंड थंब रूल. Right hand thumb rule you will be reading under this category. That means you will be reading under this category. That means you will be reading under the magnetic field of electric current, or else you can say electromagnetism. Electromagnetism के अंदर में पढ़े हो क्या? Hans Christian Ørsted you will be reading, and you will be reading right hand thumb rule. Not only that, but also you will be reading Fleming left hand rule. Fleming left hand rule भी पढ़ना है. At the end electric generator भी पढ़ना है. Sorry, electric इलेक्ट्रिसिटी आ रहा है, इलेक्ट्रिक मोटर भी पढ़ना है. द फर्स्ट जनरली 2 मार्क का क्वेश्चन नहीं आता, आ भी सकता है. डिस्टिंग्विश बिटवीन इलेक्ट्रोमैग्नेटिज्म एंड इलेक्ट्रोमैग्नेटिक इंडक्शन. इलेक्ट्रोमैग्नेटिज्म को इलेक्ट्रोमैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट भी बोल सकते हो. दैट फर्स्ट स्टार्टिंग इज आई एम सेइंग व्हाट आई एम सेइंग दैट डिस्टिंग्विश. वेरी इंपॉर्टेंट क्वेश्चन. क्वेश्चन 2 क्वेश्चन बता चुका हूं मैं अभी. I have given 2 question. First is experiment वाला, second is distinguish वाला. That distinguish between magnetic effect of electric current or distinguish between electromagnetism and electromagnetic induction. Electromagnetism के अंदर कौन आता बाबू? That is all about a famous scientist called Hans Christian Ørsted in the year of 1820. उसके बाद what he even propounded that when there will be having a flow of current, there will be having a magnetism. If there will be having not a single flow of current, there will be having not a single magnetism. उसको अगर मैग्नेटिज्म तो है, मैग्नेटिज्म कौन सा दिशा में है, व्हाट इज द डायरेक्शन ऑफ द मैग्नेटिक फील्ड, व्हाट इज द डायरेक्शन ऑफ द मैग्नेटिज्म, उसके लिए व्हाट हैपेंड, द राइट हैंड थंब रूल, राइट हैंड RHS have written right hand thumb rule, that Maxwell right hand thumb rule it came. Maxwell right hand thumb rule, Maxwell कौन है बाद में बताऊंगा. And in this also it comes Fleming left hand rule, and as well as electric motor. This is the distinguish. Coming to the EMI, what is an EMI? EMI is electromagnetic induction. Here is saying that this electromagnetic induction has been propounded by the famous scientist, which is none other than Michael Faraday. The famous scientist called Michael Faraday in the year of 1831, he even propounded that, he even stated that in case of EMI, Michael Faraday in the year of 1831, he even stated that without electricity, without current, bulb can glow. I repeat, without current bulb can go. Michael Faraday he stated that बिना करंट के बत्ती जला दे, उसे बोलते हैं माइकल फैराडे. बिना करंट का बत्ती जला दे, that means what? बिना करंट, that is having not single current in that, as well as the bulb gonna glow. How? Let me say. This is a bulb, clear? This is a bulb, this is a wire, this is a wire, this is a bulb, this is a bulb, and here he is saying that in case of EMI that बिना करंट के बल्ब जला दे, उसे बोलते हैं माइकल फैराडे. याद रखो बात, बिना करंट के बल्ब जला दे तो करंट ही नहीं है तो बल्ब जलेगा. हाउ? बिकॉज ऑफ मैग्नेटिज्म. व्हाट ही डिड ना, ही कैप्ट अ बार मैग्नेट. ही टुक अ मैग्नेट, अ बार मैग्नेट. बार में सपोज कुछ इस प्रकार का मैग्नेट, नॉर्थ पोल साउथ पोल इज गिवन. ही हैज टेकन बार मैग्नेट. व्हाट ही स्टार्टेड ना, ही स्टार्टेड डूइंग इन दिस वे. घसा उसके साइड में, that is having a conductor, right beta? This is a conductor. What happened? It is getting rub, right? Don't get worried. So he started doing this way. Once he did this way, what happened? There is having a flow of current. What happened when he started rubbing here near the conductor? It started glowing. It started glowing. This is the experiment propounded by famous scientist called Michael Faraday. How to write it down? You have to write it down. Electromagnetic induction का definition भी बन गया यहाँ पर. Electromagnetic induction is been propounded, is been discovered by the famous scientist, which is none other than Michael Faraday in the year of 1831. He even stated that without current a bulb can glow, without electricity a bulb can glow. No bulb can go with the help of magnetism. Clear baat? And not only that, but also in this way generator comes. As I said, left hand rule will be there. Here Fleming right hand rule would be there, as well as electric generator would be there. Electric generator करेंगे बात उसको. AC and DC motor, which is a little bit out of syllabus. Clear? I hope this session is very important. I hope the first part is very clear to you all people. Let me talk about the second part. Second part is very easy. Everything is easy. Everything is easy. Second part. What is given in the second part, my dear most children? The second part is given very easy. Magnet. The types of magnet you might be knowing: natural magnet, artificial magnet. Natural magnet. Natural magnet is a magnet in which there is having not a single sapient size. Natural magnet, there is having not a single sapient side. I am natural, my teaching is natural. That means that's the reason my teaching is not matching with other your concerned subject teacher or your school teacher or anyone. Their teaching style is natural. That's the reason their teaching style is not matching with my with me. Similarly, natural magnet there is having not a single there is having not a sapient side. But in case of artificial magnet, there is having a sapient size. Artificial magnet, there is having a sapient size. So artificial magnet divided into two types, that is permanent magnet, electromagnet. So another distinguish I am saying, my dear student, please write it on your copy. Permanent magnet, electromagnet. Permanent magnet are the magnet in which Permanent magnet are the magnet in which electromagnetic field, sorry, permanent magnet is the magnet in which magnetic field remain constant. Electromagnet में नहीं रहता constant. Electro मतलब electric magnet. In the magnet electric goes away. Electric कैसे जाएगा? Current से तो जाएगा ना. So that's the reason that is having electric. That means a flow of current, magnetism will produce, magnetic field will produce. No current, no magnetic field will is produced. Clear baat? And as much as high current I will be giving, lots of high current I will be giving, and lots of strong magnetic field will be there. Least current, least magnetic field. बात कराऊंगा अच्छे से. Don't take worry, don't get worried about that. So artificial magnet, permanent magnet and electromagnet. Question आया था 2017 में. Which magnet you feel the most strongest? Natural magnet or artificial magnet? Many students of mine, they have done incorrect. Many students, they have done natural magnet. No, my dear most children, artificial magnet is the strongest magnet comparison to the natural magnet. Clear? Example of artificial magnet, I magnet. I का मतलब bar magnet. Horseshoe magnet is known as U magnet. Right? Coming to the bar magnet. Let us start with a bar magnet. What do you mean by bar magnet? You might be knowing everything. Everything I will be talking in details. Don't get worried, my dear most children. North pole, south pole. Bar magnet have two poles. North pole, south pole. Like pole repel, unlike pole attract. You people might be knowing very well. Very important, very important, very important topic, very important question which I am letting you know right now. That is, list the properties of magnetic field lines. Note it down in your copy, please, everyone. List the properties of magnetic field lines. What are the properties of magnetic field lines? The properties of magnetic field lines are, देखो यहाँ पर, having a bar magnet. In a bar magnet, there is having a two pole, north pole and south pole. Clear baat? And what happened in case of magnetic field? In case of magnetic, if I'll be asking you, in this bar magnet, please say me the magnetic field. In case of bar magnet, the magnetic field भी कुछ इस प्रकार का लूप की तरह होता है बेटा. किस प्रकार होता है? लूप की तरह. देखो, लूप की तरह होता है. लूप की तरह. In this way. Clear बात? What are the properties of magnetic field? The properties of magnetic field lines are, the magnetic fields emerge from north pole and get merged in the south pole outside the magnet. उसका मतलब ये होता है कि magnetic field lines generally starts from north pole. See, look at here. Magnetic field lines generally start from north pole, or you can say in the physics word emerge. Magnetic field lines generally emerge from north pole and directly merge. Emerge and another word is merge. Magnetic field lines get emerge from north pole and get merged in the south pole, or outside the magnet. Outside the magnet. This is the outside the magnet. This is the magnetic field line का properties. Very important question. एक मार्क का चमक सकता है. Please. And this is the favorite question of the CBSE. One of the favorite question of the CBSE. So that's the reason I'm letting you know. See what I'm talking about. What are the properties of magnetic field line? The properties of magnetic field lines are that it gets emerged from north pole and get merged in the south pole outside the magnet, and it get emerge from south pole and merge at north pole inside the magnet. South pole से निकला, north pole में joint होगा inside the magnet. These are the properties of magnetic field lines. And one more important, magnetic field lines never get intersect with each other. Please note it down in your copy. Magnetic field lines never get intersect with each other. Intersect का मतलब कुछ इस प्रकार का intersect. Magnetic field lines, they never get intersect with each other. Clear बात? और एक बात, this is a magnet, bar magnet, north pole and south pole. तोड़ो उसको, फिर से north pole south pole it will create. Again you break it, again you break it, again north pole south pole will create. That means every magnet is having a north pole and south pole. Every magnet is having two poles, north pole and south pole. You cannot say after once bar magnet I'll break, that means north pole be khatam, south pole. No. Once you break another, again they will create. Once you break another, again they will create. I hope you have understood regarding the bar magnet clearly. From the bar magnet, another question I am letting you do over here. Clear? All right. I hope the session is getting interesting, people. Please let us understand regarding right hand thumb rule. Right hand thumb rule. Acha, little bit earlier, let me have a recap little bit. What I'm gonna recap, my dear most children. Let me have a recap. That Hans Christian Ørsted in the year of 1820, he even discovered that if the current passes the magnetic field, generally there is having a magnetic field. Generally there will be having a magnetism. If there will be having no current in a conductor, there will be having not a single magnetic field. Suppose this marker is a magnet, suppose this marker is a conductor, suppose this is a conductor, current hai, magnetism rahega. Current is not there, magnetism will be not there. Who is saying that? Hans Christian Ørsted. It's a very this is the correct one. But now the topic is all about what would be the direction of the current. Very important that. What would be the direction of current? To identify the direction of current, another famous scientist, he came Maxwell. He even introduced Maxwell right hand thumb rule. Maxwell right hand thumb rule, he even stated that in case of Maxwell right hand thumb rule, that he stated that he even given a direction of the magnetic field lines. How the direction of the magnetic field lines? कुछ इस प्रकार का देखते हैं. See, right hand thumb rule. This is the right hand. This thumb is generally denoting as a current. This thumb is generally denoting as a current. Clear baat? This thumb, you can see the thumb. This thumb is generally denoting as a current. How to write the definition? Definition, if the question will be not coming. This ये question नहीं आता exam में. That define right hand thumb rule. अगर भी आ गया तो क्या लिखोगे? That in case of right hand thumb rule, the thumb, this is the thumb, states the identify the direction of the current. This thumb identify the direction of the current, and the rest finger is a four, that is having a forefinger, right? The rest finger generally it gives the direction of magnetic field. The rest finger it gives the direction of magnetic field. I hope everyone is doing the same. My dear most children, please do everyone in this way, and you can see my hand. You can see my hand. See. What is it is? I said a thumb is all about a current, right? If the current is going upward, that means the magnetic field line, there will be having a circular loop. What is a loop? इसको बोलते हैं loop. This is known as a loop. जहाँ पर शुरू होगा वहीं पर खत्म. Triangle is a loop, right? Rectangle is a loop. From where it will start, there it will get the end. Circle is a loop. See, it is a current. When the current is going upward, the magnetic field line will be in this way. It will be in this way. Now, my dear most children, please say me, it is a clockwise or anti-clockwise? When the current is going upward, it will be in this way, right? So, please, my dear most children, now you say me, it will be a clockwise or anti-clockwise? It will be anti-clockwise. It will be anti-clockwise. Clear? That means if someone asks you define right hand thumb rule, you people can say that here in case of right hand thumb rule, that thumb generally denotes as the direction of current, and the rest finger generally denotes the direction of magnetic field. When the current is in upward direction, then the magnetic field will be anti-clockwise. Please write it down in your copy. When the current is in upward direction, then the magnetic field will be anti-clockwise. When the current will be in a downward direction, then the magnetic field will be a clockwise. Then the magnetic field will be a clockwise. Clear? Clockwise means generally कुछ इस प्रकार का. That means if the current is now in this way, I am talking about in this way, that means it is clockwise. Clear बात? See, you can see my clock. How it is coming? The clock is in this way. Clock का कुछ इस प्रकार का होता है. Clear? Now you see. Over. This is all about right hand thumb rule. Not only that, but also, where is my mic? Yeah. Not only that, but also in case of right hand thumb rule, these are the definition. You people can write it down. I hope the concept of right hand thumb rule is clear. Now the topic are all about Maxwell. Over. Now the topic is all about solenoid. Clock rule के बाद solenoid में जाऊंगा. Clock rule. What do you mean by clock rule? Remember always, in case of clock rule, very short I am going to talk about now. In case of clock rule, if someone is asking what is mean by clock rule, you people can say that if there is having a word of an anti-clockwise, if there is having a word of an anti-clockwise, that means anti and that is having a pronunciation of an, that means it starts from north pole. Clear? That means it starts from north pole. Now you people can say, see, bar magnet, north pole, south pole, right? From here. So this is all about, and anti-clockwise is north pole. Now clockwise is generally comes with the south pole. Clockwise generally, clockwise south pole. It is very important, you people should memorize. It will be helping you in case of solenoid, right? Solenoid क्या होता है बताऊंगा बाद में. चलो, now is all about coming to the solenoid. Coming to the solenoid, very very important topic. It is all about a solenoid. 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 What is a solenoid? Can you tell me, anyone? In the comment box, you people can say, I think that in the solenoid. Solenoid is something which behaves directly like a bar magnet. Solenoid is something which is directly behave like a bar magnet. You might be saying, sir, ये क्या है? It is a circular loop. A cylindrical circular loop generally made up of copper or an aluminum wire. It is a loop which generally made up of copper or an aluminum wire. Clear baat? The longer the loop would be, the longer the chain would be, the strongest the magnetic field will be. Remember the word, remember the fundamental concept. The strongest, the longer the chain will be, the strongest the magnetic field would be. Is it clear? जितना कम लूप उतना कम मैग्नेटिक स्ट्रांग होता है, उतना कम स्ट्रांग होता है मैग्नेटिक फील्ड. क्लियर? Magnetic field inside the solenoid can be formed with the presence of current. That means if there is having a current, then only magnetic field can be produced. If there is having no current, there is having not a single magnetic effect. If there is having current, then only what it can produce. If there is having a current, then only magnetic field can be produced inside the solenoid. अगर current चलेगा तो magnetic field will be produced, right children? If there will be having not a single current, अगर current नहीं होगा तो magnetic field भी नहीं होगा. Not only that, again something is there. Suppose 6 volt battery I have connected in this. That means somehow it will be going according to it. अगर यहाँ पर 12 लगा दूं तो magnetic field line, the magnetic field line will get increase. If I'll apply 70, then it will become more increase. If I'll apply 7, so it will get decrease. So here we concluded that in case of solenoid, that if there is having a loads of current, that means solenoid, in case of solenoid, the magnetic field can be produced because of electricity, because of charges, because of current. If there is having a current inside the solenoid, then there will be having a magnetic field. If there will be having not a single current, there will be having no magnetic field. And also magnetic field line can depends on volt, potential difference. Magnetic field lines always depends on volt. Kitna volt? Are you getting or not? It depends on this. But in case of bar magnet, it doesn't depend on anything. So in this way also, the question may come in this way: distinguish between a bar magnet and a solenoid or an electromagnet. इसको electromagnet में भी यहाँ पर आ सकता है. And not only that, again the question may come: define solenoid. You people can write define solenoid. उसके बाद ये वाला फिगर तुम्हें बनाना है. The strong solenoid, the strong cylindrical loop, a strong magnetic field would be. जितना कम उतना कम magnetic field. Clear बात? Again is there something. Let me draw up properly this. See. Suppose there is having something is there, and in which the solenoid is going from here, again from here, again from here, and again from here. Suppose what else I can say? Suppose it's a duster, and कुछ इस प्रकार का. Sir, now I can think you people can understand. it is there. इसका अंदर, that means there is having a wire. People understand. There is having a wire in which this wire went inside of it. Then again यहाँ पर बंद हो inside. Then again it will go outside of it. Again it will go outside of it. Outside ये वाला होता है outside. Outside का मतलब उसके ऊपर. It will go above of it. ऐसे कुछ इस प्रकार above. So my dear most children, please think now how, whether it is anti-clockwise or clockwise. That means when the wire is going inside, it is the कुछ इस प्रकार उसके अंदर है, इसके ऊपर कुछ बाहर होगा. It is, can you say me it is a clockwise or anti-clockwise? See, it is a clockwise or anti-clockwise. कैसे हो रहा है देखो यहाँ पर, अंदर जा रहा है फिर बाहर आ रहा है, अंदर जा रहा है बाहर आ रहा है, अंदर. That means this is all about in this way, right? In this way, right? This is all about in this way. That means it is all about what? So I can say it is all about clockwise or anti-clockwise. It is a clockwise. It is a clockwise. So अगर clockwise होता है तो clockwise a clockwise rule, south. From here it will be south, here will be north. This is very important. You have to understand. From here will be south, again here will be north. See how it is going. See. Just imagine how it is going. I am going in this way. I am going in this way. See how the loop is. The loop is in this way. That means my hand is just going on a circle. This is all about south pole, and obviously it will be a north pole. Clear? Chalo. Now let us talk about left hand thumb rule. Now we are very close to end of the chapter. We are very close to make the end of the chapter. Now let us start with the Fleming left hand thumb rule. Fleming left hand rule. What is given in the Fleming left hand rule? It may come in exam. Describe Fleming left hand rule. उसका मोटर भी है ना, अरे भाई कितना लंबा है. Fleming left hand rule. What is given in the Fleming left hand rule? Here is saying in the Fleming left hand rule that. See, this is the Fleming left hand rule. This is the left hand rule. In case of Fleming left hand rule, here is saying that each finger is remaining perpendicular to each other. The thumb finger is remaining perpendicular to the index finger. The index finger is remaining perpendicular to the middle finger. This middle finger is remaining perpendicular to the thumb finger. The thumb is generally denoted as force or a motion. You can say force or a motion. Now this index finger is generally talking about magnetic field lines, and this middle finger is talking about current. Now the two magnets are there, north pole, south pole. That means what? Suppose this is a two magnet, this is a bar magnet, north pole, south pole कुछ इस प्रकार का है, ऐसे है, ठीक है. It is downward, it is just in this way. Suppose the north pole, it is south pole, it is a north pole, here is a ऐसे कुछ south pole. Clear? So what is there in this? This is having what is given in this? What is that? This is what? This is magnetic field lines. Clear? This is all about magnetic field lines. Which kind of magnetic field lines? Important. Uniform magnetic field lines. Write it down. Uniform magnetic field lines. Uniform. Very interesting this one. It will come in exam. MCQ. Uniform magnetic field lines. Suppose for an example, I have placed a conductor inside it. Very important, huh? Suppose two magnets are there in which magnetic field line, generally you people know very well, magnetic field line is going from north to south. Outside the bar magnet, it's not there inside the bar magnet, that they are having two different, right? Two different magnets. Remember this. That's the reason north pole to south pole. Current is going upward. Now I will be asking you, find the force. Find the force with the help of left hand thumb rule. Can you find it out? Yes, you people can find it out. How? Let us see. My left hand, this is my left hand. This is my left hand. I am wearing watch in my left hand. What it is going on? Magnetic field line. What did I say? Magnetic field line generally denotes as the index finger. This is my index finger. Magnetic field line. Current, middle finger is current. This is the middle finger current. The current is going upward. That means in this way, upward. Current is going upward. This is the current I. So now, what would be the force? See, force is going just towards inside the whiteboard. The force is going inside the whiteboard. What did you observe from here? You observe that when the current is going upward, when the magnetic field in this way is in this direction, then the force will be inside the whiteboard. Is it clear? This is all about a Fleming left hand rule. I will be giving more 2 to 3 examples. Do not get worried. Now the major thing is how to write the definition of Fleming left hand rule. I hope this may come in exam. How you have to write it down? Fleming left hand rule states that each finger is remaining perpendicular to each other, in which this finger is denoted as a thumb force or a motion. This is a magnetic field line, this is a current. Here is saying, then after you have to give an example. How to give an example? By illustrating a diagram. North pole is given, south pole is given, magnetic field line is going from north pole to the south pole, current is going upward. What should be the force of the force? Here the force will be inside the whiteboard. Similarly, let me draw another one now, and also I will be giving homework to you. Let me see who is doing what. Now the current is going downward. What should be the magnetic field? See, this is my left hand. The magnetic field line is going from north to south, right? And the current is going downward, and obviously, and the force will be towards you, That means here I am saying that when the current is going downward, when the magnetic field is going in this way, then the force will be outward. और एक होमवर्क देता हूँ, चलो बताओ अभी. North and south, the current is going inward. So current is going inward. Very interesting question. The current is going inward, right? So what would be the magnetic field? The magnetic field ऐसे होगा. When the current is going inward, left hand thumb rule, current is going inward. That means magnetic field in this way. Current is going inward. Then the force will be, see, magnetic field in this way, the current is going inward. Your current is going inward inside the whiteboard. Then the then the force will be downward. The force will be downward direction. Clear baat? Now, north, south. Give me the homework. When the current is going outward direction, when the current is coming outward, downward, upward, inward, outward is very important. You have to memorize this. If the current is going outward direction, outward मतलब कुछ current इस प्रकार का है. Magnetic field line will be this, outward. Current is going outward. This outward means towards you. My current is going towards you. Magnetic field line in this way. What should be the force? Semi, you have to comment right there. What should be the force? Should be upward. Clear baat? I hope Fleming left hand rule is pretty much clear to you children. Right? Alright. Now from here only we will be talking about electric motor in the particular chapter of electromagnetism. If I can see anything, the important question, the one of the most important favorite question of the board examination, which is none other than electric motor. State the working of electric motor, state the principle of electric motor, which will be coming in the board examination. Electric motor पढ़ते हैं. Electric motor. All right. Electric motor generally comes under the Fleming left hand rule. Remember. याद रखो इसको. कैसे? Same we gonna draw north pole. Same we gonna draw south pole. Clear? A, B, C, D. You can see the book for more details, right? The figure I'm gonna talk about. Figure. I'm trying to make a figure. I hope you people like it. अगर चाहिए लगा भी सकते हो क्या ammeter if you want. See, this is known as C. Very interesting. ABCD. ABCD is what? It is a battery plus. It is a battery. And from the battery, the current always flows from the positive terminal to the negative terminal. It is a switch. And क्या होता है यहाँ पर देखो. And this is known as जो यहाँ पर this is known as split rings. Split rings, this is known as split rings, my dear most children, please understand, this is known as split rings. The function, the working of split ring is very important, which will be coming in the board examination for sure. And the design I have done over here, you can see the design which is known as B1 and B2. B1 and B2 are known as brushes. The design in this way which I have done the design, that is known as brushes. That is known as brushes, right? Clear, but this is known as brushes. You have to draw in the same way in your board examination. Brushes. The function of the brushes, the function of the split ring is very important, may come in exam if not electromotor. अगर electromotor आता है तो ये करना पड़ेगा, 3 मार्क 4 मार्क का क्वेश्चन आता है, बनता है. What is, describe the principle of electromotor, describe the working of principal motor. Please understand, you people can write it down and I will be letting you how to write it down, don't worry. What did I say before? Now it comes under Fleming left hand rule. North pole, south pole is given, electric motor is given. What did I, can you identify something? Can you identify, let me say me the work of split ring first. What is the split ring? And here axle has been connected. Split ring is what? The split ring generally holds the axle. Suppose this is the split ring, what happened? The split ring generally holds the axle. Axle move होगा तो split ring भी उसके साथ move होगा. Right? Suppose this is an axle, this is a split ring. When the axle is getting moved, the split ring will also get moved. But the brushes will remain the constant. Brush will not move. Brush means what? A brush is generally giving a supply to, brushes means giving a supply like your current is giving. Brushes, right? Which I will be saying later on. Can you find over here something? What is going upward? Current is going upward. That means you see current is going upward. Magnetic field line in this way, then the force will be downward, the force will be inside. Clear baat? If the current is going upward, if the magnetic field in this way, then the current will be going downward, then the current will be going inside, sorry, force will be going inside. The current is going upward direction, the magnetic field is going this way, then the force will be inward direction. Baat clear? Baat clear? And if the question will be coming right up principle of electric motor, the first thing you have to write it down. Electric motor is a device which convert electrical energy to mechanical energy, which convert electrical energy to the mechanical energy, to the mechanical energy. That means what I'm gonna say, electrical energy, that means electric motor is a device which convert electrical energy to the mechanical energy. Example, ceiling fan, grinder, and what more? Refrigerator, right? These are the example. Then after what you gonna do? Then after, if agar kuch aise prakar ka question hai, to describe the principle of electric motor, first you have to write the definition. Example, definition is electric motor is a device which converts electric energy to the mechanical energy. Then after giving an example like ceiling fan, grinder, refrigerator, then after you have to do a figure. This is the mandatory figure you have to do. Figure banana hai. In this figure, here is saying that ABCD is a conductor. You can see ABCD is a conductor. ABCD is a conductor which has been connected to a battery, which has been connected to a 12-volt battery. Clear? And S1 and S2. Here let me say S1 and S2 are the split rings, and B1 and B2 are the brushes. And with the Fleming left-hand rule, we observe that when the current is going upward in case of AB, in the Fleming left-hand rule, we observed in a conductor of AB, the current is going upward, the magnetic field is in this way, then the force is going downward. That means something. See, suppose ABCD is given. This ABCD is given. Suppose ABCD is given. Now the current is going here. In this way, the current is going upward. That means the force will be in this way. That means after half turn, what will become? Something in this way. After half turn, कुछ इस प्रकार का बनेगा बेटा. After half turn, why it will be in this way? Because it is a force now. The current is going upward. The current is going upward. Then the force will be downward. तो ऐसे ना force यहाँ पर लग रहा है ना. That means it will become something like that. It will turn. After half turn, after half turn something, somehow it will become in this way, that is CDAB, somehow it will become in this way, CDAB after half term, कुछ इस प्रकार था. Now understand ABCD, how it is ABCD. This is A, this is B, this is C, this is D. After half turn it will become something like this. That means ये वाला AB will come over here after half turn. This is ABCD. After half turn it will become something like this. B हो जाएगा यहाँ पर B, यहाँ पर A. Is it clear? So how to write it down as a principal working, that ABCD is a conductor. In case of AB, where I left, in case of AB, the current is going upward, then the force will be downward, force will be inward. In case of CD, the current is downward, then the force will be outward. उसके बाद after half turn we find, उसके बाद you have to draw something like this figure. Then after you have to state that after half turn, then after you have to draw a figure, then after the principle of working of electric motor is over. This is the show. And remember, electric motor always come under the Fleming left hand rule. As you know very well, ऊपर गया, अंदर चला, नीचे आया, बाहर निकला. In case of CD, clear बात. So electric motor has been completed. Now coming to the last portion, EMI. Electromagnetic induction, little bit I said before that, जो बिना करंट का बल्ब जला दे उसे बोलते हैं माइकल फैराडे. जो बिना करंट का बल्ब जला दे वो होता है माइकल फैराडे. That means without current bulb glows, that is known as Michael Faraday. If the question comes define electromagnetic induction, you have to write it down. The electromagnetic induction is discovered by the famous scientist called Michael Faraday in the year of 1831. This phenomena stated that without current a bulb can glow with the help of magnetism. Then after, अगर 2 मार्क का आया है, then after you have to draw a figure, simple straight in this way. इसको ऐसे ऊपर नीचे कर देना. North pole, south pole is given. Then after, whenever, and remember, अच्छा, one more thing. How the bulb will be glowing? Bulb will be glowing with the help of movement of magnetic field. For an example, this is a circular loop, right? This is a conductor. This is a conductor I. This is a conductor which is there in the circular loop. Conductor which is there in circular loop conductor in which there is having not a single current. It is a conductor where is having not a single current is given, only conductor is there. What happened? Now the magnetic field. Now I have taken magnetic field, 1 magnetic field, 2 magnetic field, 3 magnetic field, 4 magnetic field, 5 magnetic field, 6 magnetic field, 7 magnetic field. What I will be doing? The reflection of magnetic field. That means बढ़ा भी सकता हूँ, कमा भी सकता हूँ. What happened? Suppose there is having a conductor and in which this is a magnet. I am doing in this way. That means I am doing in this way. If I will do in this way, then only the bulb can glow. Then only here you can find the current. If you will keep here constantly, you cannot find the current. Constant रहेगा तो current कभी find नहीं कर पाओगे. That means if the magnetic field is constant, there will be having not a single generation of current. If the magnetic field is constant, there will be having not a single generation of current. If there will be having a flow of magnetic field, कभी कम होगा, कभी ज़्यादा होगा, कम ज़्यादा, decrease, increase. Now it is 7 magnetic field. Now अभी कुछ 2-4 कर काट देता हूँ. Now it is having 2 to 3 magnetic field. Again 7 कर दो, कम कर दो, बढ़ा दो, कम कर दो, बढ़ा दो, increase, decrease. Then only the current will flow. Now I will be saying no, I will just keep here. The current will flow. No, the current will not flow. That means you have to start moving. You have to move. Then only the current will flow. Clear baat? Now the very topic is, acha. Now the current will flow. What would be the direction of the current? That is also somehow a justified question. Another, if the, what would be the direction of current? The direction of current generally it's been propounded by Lenz's law. It has been propounded by another scientist, Lenz, or else you can say it's a Lenz's law. What is given in the Lenz's law? Lenz's law oppose karta hai. For an example, if North Pole and South Pole is given, suppose a bar magnet is given and another it is given. What happened? When this bar magnet is coming here to this, suppose to this magnet, what happened? It never allows, कभी इसके पास में जाने नहीं देता. क्यों? Oppose करता है. Like pole repel, unlike pole attract each other. ना पास आने देगा ना दूर जाने देगा. Is it? That is all about a Lenz's law. What happened? This is a bar magnet. If the bar magnet is going close to each other, this one will oppose. Hey, don't come near me. If this one is opposing, that means अगर ये oppose करता है तो यहाँ पर क्या होगा बताओ? यहाँ पर साउथ पोल नहीं होगा क्या? If this is opposing, that means what? If this is opposing, if this magnet is opposing, what would be the direction of this magnet? The direction of this magnet is S. Why? Because like pole repel each other, unlike pole attract each other. If this bar magnet is going close to each other, if there would be having north pole, if there would be having north, definitely they will get attract. Unlike pole attract each other. I am a boy, you are a girl, we both will get attract. But here the magnet will get attract. Similarly, that's the reason it is having a south pole. It opposes. Lenz's law, what he said, that it opposes. Generally that will oppose. Similarly, another north pole, south pole. If this is going back, ये बोलेगा जा दूर मत जाना कि पास मत आना. You have to maintain a social distance from us. That is all about. Here will be north pole. Why it is coming farther right? So it is a north pole. This is all about the show, which has come to the end in case of Lenz's law. In case of Lenz's law, right? It opposes. I hope the session is really helpful to you. The board questions, the question number 1, which is very important question for the board examination, that is, first is describe the experiment of Hans Christian Ørsted. Very important question. Distinguish between electromagnetism as well as electromagnetic induction. Secondly is all about, I did not say about right hand Fleming right hand rule, right? Induced current wala nahi bataya na. All right. Okay, I'll talk in my next lecture, right? And what happened, another question, important question is permanent magnet as well as electromagnet. What is a solenoid? Describe the electromotor, principle of electromotor, working of electromotor is very important, my dear most children. And Lenz's law, give what do you understand by the Lenz's law, that is also very important. Somehow it comes true, that is important. What more left? Another Lenz's law as well as Fleming left hand rule. What do you understand by the electromotor, Lenz's law as well as electromagnetic induction? Who has propounded electromagnetic induction? Right hand thumb rule wala question nahi aayega. So these are the scenario which I have talked over here. I have the session is really interesting, really amazing. So thank you very much, and please share to all kind of juniors. Please help me out to share the video, to share the Telegram link to all kind of juniors, those who have started their 10th grade now. Thank you very much and have a great day.